Hello viewers, welcome back to my channel. Today I'm going to teach you the real numbers and their decimal expansion. We already know the meaning of real number, and if you divide p by q, then by dividing we'll get two situations. Either the remainder becomes 0 or not become 0. If the remainder becomes 0, then that kind of expansion, decimal expansion, is called terminating expansion. This is very important. So what is terminating expansion? If the remainder becomes 0 when we divide the rational number in the form of p by q. Let us take some examples here. So we have three examples here. I'm going to solve all these three and how the expansion become terminating. I'll show you that now. Let us take one first example, that is 7 by 8. That means you have to divide 7 by 8. Since 7 is lesser than 8, you need to add point here. If you put point here, you need to substitute 0 here. So you'll get 8 8 is 64 and 6. If you subtract this, put 0 here. 8 7 is 56 and 4 here, again 0. 8 5 is 40. So if it goes on like this, the remainder becomes 0. Then this kind of expansions are called terminating expansions. Let us take again another one, that is 1. Again 1 is less than 2, put 0 here, point here and put 0 here. 2 5 is 10 and the first of itself the remainder becomes 0. So 1 by 2 is also a terminating expansion. Let us take a bigger number, that is 639 divided by 250. So 251 is 250, 252 is 500, 250 times of 3 is 750. So 252 times is 500 and the remainder is 130. So 931. 139 is lesser than 250. You put a point here and substitute 0 here. And if you goes on do this, 255 is 1250 and the remainder is 140. Again 140 is less than 250, put one more 0 here. Again the same thing, 255 is 1250. So 0 5, so 1 carry overs here and 3 minus 2 is 1 and again put 0 here because of we have already taken point here. So 256 ja 1500, then the remainder becomes 0. So the meaning of this is whenever you do a decimal expansion or division of two rational numbers, then the remainder becomes 0. That's a one case. Then that numbers are called terminating expansions. Let us go to the next case, the second situation. If the remainder does not become 0. So as I said, there are two situations arises when you divide p by q. The number one is remainder becomes 0 and the second one is remainder does not become 0. Then this kind of terminating expansions are called decimal expansion are called non-terminating or repeating, or another name is there, a recurring expansions. Let us take one examples here. So 1 by 3, 1 by 7 and 7 by 8, etc, etc. These are the examples for non-terminating and repeating expansion. What is the meaning of non-terminating? Non-terminating means the remainder does not become 0. And what is the meaning of recurring? I'll show you how. Let us take the first problem. Divide 1 by 3. Again 1 is lesser than 3. Take point here and substitute 0 here. 3 3 is a 9. Again 1 is a remainder. Put 0 here. 3 3 is a 9. Again 1 here. Put 0 here. 3 3 is a 9. So if you do the division of 1 by 3, you will get 1 as a remainder always, and this expansion is goes on like infinity. So this is also goes on. Then we can write this as 1 by 3 is equal to 0.3333, etc, etc, etc. And to shorten this, you can write 0.3 bar. So this kind of statement shows whenever you do a decimal expansion of a rational number, in the second case, if the remainder does not become 0, then this kind of expansion is called the non-terminating and repeating. So you can see here 3 is repeating. 3, 3, 3, and it will goes on like this. And for that reason, I have substitute bar here. Let us take second one, 1 by 7. Divide 1 by 7. Again, 1 is lesser than 7. Put point here and substitute 0 here. 7 ones are 7, 3, and put 0 here. 7 fours are 28. And if you subtract this, it will come to again 7 twos are 14. If you subtract, you will get 6 as a remainder. 7 eights are 56. 4 here. 7 fives are 35. Again 5. 7 sevens are 49. Again the remainder is 1. And if you substitute 0 here, and you can see if we start with 1 and we ending up with 1, and this expansion whatever we done till here, it will expand again. So again, if you do the division statement, it will start with 1, 4, 2, 8, 5, 7. It will go on like this. So I can write 1 by 7 as 0.142857 whole bar. So this is called terminating expansion, and these things are repeating. So in this problem 3 is repeating in all the ways from here to here, and after 142857 again 142857 will come. For that reason I have put bar here. So this kind of expansions are called non-terminating because it is the remainder does not become 0, and the answer what you get here is repeating or recurring. So till now we have done a rational number. For rational number decimal expansion, we get two situations. Either it is terminating or it is non-terminating repeating. Let us go to the second case, that is irrational number. In irrational number, if you do the decimal expansion, it would be only one case, that is non-terminating, non-repeating. So the remainder does not become 0 and the decimal expansion is not repeating. Let us take up some examples here. So we have see here pi, the value of pi is 3.141. If you see here, there is no a bunch of things or a single digit is repeating somewhere here. Root 2 also you can take up. There is a number of numbers here and this goes on like this. So its meaning is the expansion does not become end, that is remainder does not become 0, and there is no repeating kind of things here. You can see here also 01001 0001, and there are more zeros coming next also. So we can say this is a rational number. So I hope all of you understood. Don't forget to like, comment, share and subscribe. Thank you.